Okay, so in this video, we start maximizing profits second order condition. Exciting, exciting. We now check if the second order conditions are met. There are two things we need to check. First, recall that the first order condition can give us a local minimum or local maximum. Okay, so for Q to be a local maximum, we need marginal cost to be increasing at Q. Second, we need to check if the problem has a corner solution, that is, check to see if it is optimal to set Q equals 0. Recall that the firm's constraint is that output Q cannot be negative, Q greater than or equal to 0, duh. Sometimes it will be optimal for the firm to shut down and produce 0. The firm will choose to shut down and produce Q equals 0 if the price P is below minimum average variable cost. To illustrate the condition that the marginal cost must be increasing, consider the example in figure 3.16a. Okay, finally, so it's all about interpreting these graphs. Figure 3.16, A and B. A is first order condition. Yes. A is first order condition. The whole thing is second order condition. Profit given price PH anyways. To illustrate the condition that the marginal cost must be increasing, consider the example in figure 3.6a. The graph shows the firm's marginal cost, average cost, and average variable cost at price PH. Yeah, P1H. At price PH, there are two quantities that satisfy the first order condition. PH equals MC. Okay, so that's PH has to equal MC. So we have to have a quantity where it equals MC right there. There are two quantities that satisfy that. Quantities Q1H and Q2H. Figure 3.16b, yeah, shows the firm's profit for different quantities given the same price PH. The firm's profit given different quantities. I think it's very obviously Q2. We're saying with Q1H, we lose money is what happens there. Okay, so it's hard to interpret the entire graph, but the outcome is pretty simple there, that we want to have that Q2H on the right. The MC is decreasing, profit is convex in this region, hence we have a local minimum at Q2H. Local min is decreasing, profit is convex, hence we have a local minimum. Oh, at Q2H, the MC is increasing, profit is concave, hence we have a local maximum. Oh, they're talking about over on the right over there. Okay, good. Yeah. Therefore, the firm should choose Q2H as the optimal quantity. Obviously, I suppose. Yeah. What is true about Q2H? It's above the AVC and it's above AC. Yeah. Let's now try to understand the shutdown rule. The firm wants to choose the Q that maximizes profit, which is the same Q that maximizes variable profit. Variable profit at Q equals 0 is simply 0. At Q equals 0, the firm is not producing, hence has 0 variable cost and 0 revenue. Therefore, the firm will produce a strictly positive Q if it can make a positive variable profit, and it will produce Q equals 0 if it cannot make a positive variable profit. If the price P is lower than AVC of Q, for every possible Q, the firm cannot earn a positive variable profit. On average, it costs more to produce each unit than how much money the firm can earn for each unit. It is then better to produce 0. Of course, the firm is producing 0 and has to pay a fixed cost, then the firm's profit is negative. Consider the same firm, same cost function from figure 3.6a. Consider the same firm, same cost function from figure 3.16a, that's what we just had. But now suppose the price is lower. The price is now PM, so we have new figure 3.17. Here's that. Okay, so now we're between the AVC and the AC. We want to be above that AVC, I think we're going to find. 3.17 here. Given this price, the firm should choose to produce the new quantity Q2M. Yeah, Q2M. We always want to be on the right there. We would never be over on the left. Over on the left, Q1M, we're going to be below the AVC. We always have to be above that AVC. That's one of the basic outcomes for this, is to be above the AVC. Given this price, the firm should choose to produce new quantity Q2M. However, at this quantity, we can see from 3.17a that the price PM is less than the average cost of Q2M. Therefore, the firm is producing but earning a negative profit. Why? We can see the answer in figure 3.17b. It does not matter the quantity chosen by the firm. The profit will always be negative. In this dreadful scenario, the best the firm can do is to produce Q2M. From figure 3.17a, we can see that at Q2M, the price PM is always higher than the AVC of Q2M. Yes, good. Yeah, so all of it is a negative profit, unfortunately, if we see that over there. Yeah, we want to be above the AC as well, but we're talking about above the AVC here. From figure 3.17a, we can see that at Q2M, the price PM is higher for AVC Q2M. Therefore, the firm is able to earn a positive variable profit. It is worthwhile for the firm to produce and make some money. However, the price is so low that this positive variable profit is not enough to cover the fixed cost. That is why the firm has a negative profit. Yeah. So we always have to be above the AVC, but realistically, to make a profit, we still have to be above the AC. Yeah, so here we're between. We are between the AC and the AVC. We very much care about this, but just like it was in 3.16 above, we want to be above the AC as well. If we're in between the AC and the AVC, it just doesn't cut it. We never want to be over here. It just doesn't make any sense to be over there. Any example problem is always going to have something where it's going to be that Q2. Okay, so in the next video, we are going to consider an even worse scenario, so that'll be fun.